There are many challenges doing astronomy in Malaysia. Among them are weather and light pollution. Due to our geographic location close to the equator, the weather is unpredictable. We have more cloudy nights than clear nights. Starfinder Astronomical Society organizes monthly imaging and observations party or IOP for the last 6 years. We bring our members to places outside the city, away from light pollution, to image and observe the night sky.
Hi, I'm Fonky. Many people ask me questions during MCO. Is it possible to do astronomy in a light polluted city? For students and teachers, I will talk about how you can get involved in the learning of astronomy and perhaps even get yourself compete internationally. And lastly, I will talk about why astronomy does matter. So see you at 2:30 today.
There are many challenges doing astronomy in Malaysia. Among them are weather and light pollution. Due to our geographic location close to the equator, the weather is unpredictable. We have more cloudy nights than clear nights. Starfinder Astronomical Society organizes monthly imaging and observations party or IOP for the last 6 years. We bring our members to places outside the city, away from light pollution, to image and observe the night sky.
Hi, I'm Fonky. Many people ask me questions during MCO. Is it possible to do astronomy in a light polluted city?
For students and teachers, I will talk about how you can get involved in the learning of astronomy and perhaps even get yourself compete internationally. And lastly, I will talk about why astronomy does matter. So see you at 2:30 today.
Sound check, sound check. There are many challenges doing astronomy in Malaysia. Among them are weather and light pollution. Due to our geographic location close to the equator, the weather is unpredictable. We have more cloudy nights than clear nights. Starfinder Astronomical Society organizes monthly imaging and observations party or IOP for the last 6 years. We bring our members to places outside the city, away from light pollution, to image and observe the night sky.
Hi, I'm Fonky. Many people ask me questions during MCO. Is it possible to do astronomy in a light polluted city?
For students and teachers, I will talk about how you can get involved in the learning of astronomy and perhaps even get yourself compete internationally. And lastly, I will talk about why astronomy does matter. So see you at 2:30 today.
There are many challenges doing astronomy in Malaysia. Among them are weather and light pollution. Due to our geographic location close to the equator, the weather is unpredictable. We have more cloudy nights than clear nights. Starfinder Astronomical Society organizes monthly imagings and observations party or IOP for the last 6 years. We bring our members to places outside the city, away from light pollution, to image and observe the night sky.
Hi, I'm Fonky. Many people ask me questions during MCO. Is it possible to do astronomy in a light polluted city?
For students and teachers, I will talk about how you can get involved in the learning of astronomy and perhaps even get yourself compete internationally. And lastly, I will talk about why astronomy does matter. So see you at 2:30 today.
I was looking for witness of domestic abuse. There are many challenges doing astronomy in Malaysia. Among them are weather and light pollution. Due to our geographic location close to the equator, the weather is unpredictable. We have more cloudy nights than clear nights. Starfinder Astronomical Society organizes monthly imaging and observations party or IOP for the last 6 years. We bring our members to places outside the city, away from light pollution, to image and observe the night sky.
Hi, I'm Fonky. Many people ask me questions during MCO. Is it possible to do astronomy in a light polluted city?
For students and teachers, I will talk about how you can get involved in the learning of astronomy and perhaps
sound. All right, can you hear my voice? You can see my desktop, right? So give me a second to adjust this. So can you see my slide? Can you see my slide? Okay, good. All right. Yes. Let me start it now. Okay. All right. Salam sejahtera. Semoga semua sehat dan selamat. Terima kasih Planetarium Negara yang menjemput saya dan Starfinder untuk ceramah Meet an Astronomer ini. Ceramah ini ada 3 bahagian. Bahagian pertama ialah mengenai astronomi imaging di bandar, terutama di bandar yang mempunyai pencermah cahaya seperti di KL. Bahagian kedua ialah mengenai Olimpiad di bidang astronomi, terutama untuk pelajar dan guru sekolah menengah. Yang bahagian ketiga ialah sama ada astronomi ini masih penting dalam dunia ini. Bahagian pertama dan bahagian ketiga akan disampaikan dengan bahasa Inggeris dan bahagian kedua dengan bahasa Malaysia. Saya harap ceramah ini tidak akan melebihi 1,5 jam. Okay, how are you everyone? I hope you are well and safe, and thank you Planetarium for inviting me doing this talk, Meet an Astronomer talk. This talk will have 3 parts. The first part is about the questions that I have been asked a lot, which is about imaging. Is it possible to doing imaging in the city, especially like a light polluted city like KL? And the second part is about the competition, okay, the Olympiad competitions in astronomy. Can I see the slide? Somebody say cannot see the slide. Okay, and the third part is actually about whether astronomy is still relevant in today's world. Okay, so yeah. Okay, can you all see the slide? Okay, let's introduce our organizations. Now, Starfinder is a non-profit organization. We are non-governmental as well, founded in 2004. We have a few hundred active members. We organize star parties and outreach activities. The slide doesn't change. Really? Hold on. There's some technical issue here. Okay. So from PowerPoint. Can you see it now? Can see now? Can you see now? Can see now? Okay, we organizes star parties and outreach activities, and we also organize the Malaysia Olympiad on Astronomy and Astrophysics, known as MOAA. Okay, and we actually promote. Our objective is to promote the learning of astronomy. All right. Okay, let's move on. So a bit about myself. My name is Fong King Yin, and people used to call me Fonky. And I am from Kuala Lumpur. I'm an amateur astronomer, and currently I'm the president of Starfinder. I have been the team leaders for Malaysia IOAA team 2015, 2017, and 2019. I also act as a astronomy club coach in Kuan Ching. So yeah, I operate a tiny mini observatory called Fonky Observatory, which for my private use. To earn a living, I'm an IT consultant. Still cannot see my screen. Still can't see my screen. Why? What happened now? Okay, sorry about that. We had some technical issue. All right, just give me a second. Let me arrange this a bit. All right. Okay. I think the issue is my PowerPoint slides. So let me restart the PowerPoint and see. PowerPoint. Okay. Yes. Can you see me? Okay, I believe the problem is solved. Can you see it now? Okay, let's talk about let's talk about the topics today. So astronomy is about studying objects beyond planet Earth. We use observations as a mean to study astronomy. Okay, I believe everybody can see the screen now. Please let me know. Okay, I'm going to talk about it, continue with my talk. Yes, we use observations to study astronomy. Before I answer the question whether we can do imaging in the city, we need to understand how we know all these physical property of the universe. Okay, so you more or less understand where I'm going now. So you need to learn a bit of astronomy before you know the answer, right? So we live on a planet Earth. So we have an atmosphere that's protecting us. So this atmosphere itself, okay, allow some radiations from space to reach the surface of the Earth, and some not. So some harmful radiations like X-ray, uh, gamma ray, and UV are actually blocked, okay, and these are blocked. So this is what we call the visible spectrum, that these are the lights that we can see. So our visible spectrum is centered around the color dominated by our sun, all right. So yeah, this is the so radio wave and also visible wave can reach the surface. So all we can do on the surface of us to do observation is actually through this called the optical windows. That is where we can see the stars, because only at the wavelength or from this visible wavelength we cannot see ultraviolet or infrared. All right. Okay, let me check how how can you guys see the slide? Okay, seems to be okay now. So let's go on. So yeah, so we do experiment. Okay, usually we do experiment like we uh, we want to prove that the existence of hydrogen. What we do, we actually light a spark, and you hear the pop sound, and we know that there's hydrogen. And if we want to measure a temperature of something, we use the thermometer or we use a pyrometer. So during SOP, during MCO, or right now the recovery MCO, we go everywhere. We have this temperature check. This is the same thing that we do. That's how we measure temperature. But how do we measure the temperature of a very distant object? So we can't just send a rocket to the sun and measure the temperature there, or collect some sample back and to see whether there's hydrogen there or not. So this is not feasible because the sun is very, very hot. All right. So what do we do? Okay. So well, a few hundred years ago, by observations and experiment, scientists found a relationship for objects, the color of the objects. Suppose that we have a red hot iron, okay, burning iron, and this iron only emit light but doesn't absorb light. And this piece of iron here will, the color of the iron is actually represent the temperature. So different color, different temperature will have a peak emissions of certain color. Although actually the object itself emit all the spectrum, but it will peak at certain color. So by looking at the color of the object, we actually can estimate the temperature. This is how we know the temperature of the stars. So yeah, for red color stars, the surface temperature is about 600 to 800 Celsius. And for the blue star, it's extremely hot. It can reach 10,000 or 50,000 Celsius, okay? So, and usually in astronomy, we don't use Celsius, okay? We use Kelvin, all right? So another phenomena that Isaac Newton, the guy who hit by an apple, okay, he one day discovered that our sunlight is actually have 7 colors. Actually, the sunlight not only have 7 colors, the sunlight is actually have a continuous color from red until violet. However, the impressions given that we have 7 colors are caused by these lines. These lines are known as the absorption line. So how this light come about is when something is hot, the radiation emitted by this object is actually at all wavelength. Okay, as I told you just now, some wavelength is actually denote the color stronger in certain wavelength because of the temperature. So, but when this light that pass through some gases, this energy will be absorbed by the gas. So the gas absorbs the energy, the atom absorbs the energy in the form of photon. So because of the energy absorbed, when have enough energy is absorbed, one of the electron is displaced. So that is what happened because the black line. So this dark line is actually caused by energy absorbed by the atom and displaced an electron. On the same note, that same principle, an atom can actually regain an electron. So when it regains an electron, it needs to release the light. So we have this emission light. The absorption and emissions have very specific energy. So the atom to jump from here to here need to absorb or emit the same amount of energy. It cannot be more, it cannot be less. So this is actually manifest in the spectrum itself. So if for hydrogen, this is very specific. It has to be somewhere here. Okay. So this is how we know what is inside a star, or what is inside, what elements are inside the sun or the star. Okay, so you can actually build in modern days, we actually simulate this using ionized hydrogen, and we actually can find out hydrogen, that the specific wavelength emit by hydrogen that have gained or lost a single electron. So this is a periodic table you study in probably study in high school, and you actually can see with all these elements, they are associated with specific lines, either absorptions or emission lines, and these are the fingerprints of the element. So we can detect this line, we know the compositions of the object itself. So long the object is either absorb or emit such light, we know that if it's absorptions, meaning that there is a gas in front of the source. Okay, if it's emission, that means that it absorbs energy. There's a strong energy presence with the object. So this is how we learn about the object. So this is the sun spectrum. So we can see that we have hydrogen over here, we have helium, and many other elements detected using this method. So this method of detection is known as spectroscopy. You can actually build a device to do the measurement. It's called a spectrograph. So you can use prism or any other thing to build it, or you can actually use a CD to reflect the light. But using this method, it does work. This is my little experiment more than 10 years ago. Actually, I can identify the spectrum of these stars, but they have to be very bright stars. All right, so we can imagine light coming from a source is actually expand like a sphere outside. So originally the light is in a dot. Eventually it will grow at the distance, okay, until it reaches your eye. So when you look at, this is your eyes. When you look at this candle, you see the candle very bright when you in a specific distance like this, okay, which is very close to the candle. So if you double the distance, the candle will look 4 times smaller, okay, and the energy is actually 4 times bigger. Okay, this is because the distance double, and the area that the energy from the candle is spread over 4 times the area. So similarly, if you increase the distance to 3 times, I'm sorry, this is supposed to be 3, then the energy will spread over 9 times the area. So the energy will be much weaker. Okay, so this is known as inverse square law. So our eyes is actually a very limited in terms of capability, but that's all we have. So how do we enhance the capability of our eyes? What we can do is that we can use a telescope. Now, a telescope, our eyes have a pupil that actually where light can pass through, which is between 4 to 7 mm. Why there's a difference is mainly due to age. Younger people will have a larger pupil. Older people like me probably have maybe 5 mm left of the pupil. So as you go older, your pupil can no longer dilate that much. But as compared to a telescope, which is 60 mm, okay? So 60 mm is actually have a larger light collection area. So we can use the telescope to actually enhance our capability. So yeah, so how we actually see lights, the brightness of lights. When we see something in the sky, a star, the brightness, if you feel that something is twice brighter than the other star, actually in reality is 2.5 times brighter than the, the other star. So this is a human a physiology. Okay, so whatever you feel that is twice, if you hear a sound is twice louder than the other sound, it's actually 2.5 times louder. Okay, so in astronomy, we actually measure the brightness of a star called magnitude. So magnitude is run from a negative number to a positive number. The smaller the number, the brighter the star is. So our sun have an apparent magnitude of negative 26.5. And the brightest star, other than our sun, which is negative 1.5. So Hubble Space Telescope have the capability to detect star at the magnitude of 28.5. This is amazing, right? So, okay, in Malaysia, we can see that many people operate observatory. So I have a small observatory on top of a building and using a telescope to do imaging. And you also can see this is a observatory I recently visited, run by Dr. Roby. He got much bigger telescope than mine. Okay, so telescope is a tool that we can use to observe and to actually collect data and collect lights, a way to enhance our capability. So instead of using eyes to see through a telescope, we also use a camera, and this camera is actually many times more sensitive than our eyes. So this is usually how amateur or professional astronomer conduct astronomy observations. It's in very rare that actually we use eyes to actually see the object because we can't record it. Our eyes can record it. Of course, in the past, there are people actually draw what they have observed. So most of the data are actually collected by camera. Okay, so this is the Langkawi, our Langkawi National Observatory. Okay, so this is their, I think it's 20-inch RC if I'm not mistaken. Okay, and this is another observatory in Telok Kemang, Port Dickson. Okay, I can't remember the name of the hotel, and you stay at the hotel, you actually can have a tour of the observatory. All right. So yeah, so one of the reasons we're building bigger and bigger telescopes. So this is actually a basketball field. I think this is a tennis field, and compared to the telescope around the world. So the biggest one is this one at the background. Okay, it's called overwhelmingly large telescope. Okay, and this is not telescope. These are Starfighter logo. Okay, so yeah, we are building bigger and bigger telescope because there are a few reasons. We want to collect more lights to observe fainter object, and we also want to increase the resolutions. A large telescope also can resolve smaller object. Okay, all right. So in Malaysia, we have a serious problem. You look at the light pollution. This light pollution graph. So this is KL. Okay, so you can see that we have very little places that in the Peninsula Malaysia as compared to the East Malaysia that remain not polluted by light. And the way that we actually determine the quality or the sky, how how light polluted is by a system called the border scale. Okay, so places like Kuala Lumpur, inner city have a border scale 9, and you hardly see many stars. The reason is the background is actually as bright as the star, so we can only see star that brighter than the sky. Okay. In a smaller area, a little bit away from the city, you have border 7, and you have outskirts like small town. You probably have border 5, and you have rural area. You got border 3, and you have excellent places that have border 1 sky. Okay, so these are the approximate magnitude that you actually can observe based on different border scales. So if you are interested to see Milky Way, okay, so from here to here is actually not visible. Okay, at least you have border 5 that you can actually see Milky Way only on the scenic. Okay, so we most of the time, if you want to look at or do imaging and do observation, we have to have good sky. Okay, uh, but can we do anything, any imaging in the city? Of course you can. You can do planets. So this is lunar eclipse. You can do things like this because these objects are very bright, and through the camera you actually have more you are more sensitive, okay, than the eye. So you probably can pick up more informations and record more information than your eyes. Okay, so we can do like this is a moon. The last few hours of the moon. Okay, you can even do daytime moon photography, or you can do many planets. Okay, yeah, this is during MCO. Oh, this not. This is last year, I think. Yeah, this is not during MCO. This is during This is recently the neowise. Okay, so neowise also can be imaged in the city itself. This is bright enough through a telescope, but not seen through the naked eyes. Okay, so another way we can do this is actually do what we call a narrowband imaging. So over here, we look at this. This is actually the light pollution spectrum. Okay, and you notice that not the entire visible wavelengths are actually uh, affected by light pollutions. They are specific sweet spot over here. So including H alpha, okay, you may not get all the best, but you get more data as compared to this range. So you can have H alpha, S2, O3. These are not affected by least affected by light pollution. The reason this region is affected by light pollution is because most of our light, like mercury, sodium light, and so on, are concentrated, or other like tungsten light and all those are concentrated over this spectrum. So and nowadays over here, if all this spectrum is also start increasing because we are changing to LED light. So LED light without a filter is actually bad for astronomy. So some of the more advanced LED light, slightly more expensive, actually have a filter to protect against light pollution in some of these important spectrum for astronomers. Okay. So what is narrowband astronomy? So narrowband, we use filters like this that actually block off other lights and only see a very specific wavelength. Say for example, like H alpha, okay, you can only observe the H alpha wavelength. The other wavelength are blocked off. Okay, so basically we use 3 to 4 narrowband filter. They are the H alpha, S2, O3, and sometimes H beta. And usually what we do, we use a monochrome camera like this. Okay, but nowadays also they have another type of filter that encompass 2 or 3 wavelengths. Cost more expensive, but you actually can use it to image, uh, use color sensor or color camera to do imaging. And there are also light pollution filters that you can use, but less effective. All right. So this is an example here. I'm not sure whether you can see because over here it's a bit dark. Okay. So we capture all these informations over here. So we capture in monochrome. Okay, and we assign a color to it. So why we do that? You come back to see. You notice that this is H alpha. This is S2. Both of them are red in color. So if we image through these two filters, we will get 2 red color. Okay. If you image to O3, you will get a green color, a light green or a teal green uh, data, and then H alpha and S2 are both red. So if we image both H alpha and S2 and assign them to red color, then you will not see these features individually. So the purpose that we assign different color is to be able to observe how individual gases interact in a specific object. Okay. Now, narrowband can only use to image things that have ionized gases. Okay, have a lot of ionized gases like nebula, planetary nebula. Not for galaxy. Galaxy, basically all the lights coming from the star, they are actually broadband emissions. So they are not suitable for narrowband imaging. So this is a combination of just now what we saw, the previous slide. Okay, so when they combine, this is actually known as the network nebula, and the combination using S2, H alpha, and O3 is known as the Hubble palette, which is pioneered by the Hubble Space Telescope. Okay, but I don't quite like the combination, so I do another one, which is called HOS, using hydrogen alpha for red, which is closest to its natural color, O3 for green, again closest to its natural color, but the S2 original red is assigned to blue. So this is known as Canada France Hubble Telescope palette. Okay, CFHT palette. Right. Okay. So this is M42 Orion Nebula. Now you should be able to see it in the morning. Okay. So this is image under HOS. Okay. But we sometimes do a bit differently. We actually use longer exposure in certain wavelength. For example, in this case, I actually suppress the hydrogen alpha and emphasize more on oxygen and S2. And S2 data usually are very, very little. And this is actually image in KL. Okay, for the next all the objects that I'm going to show you, almost all of them are imaged in KL itself. So that is the purpose of showing you that we can actually do deep sky imaging even at KL. Okay, so this is actually a very rare object to be imaged. It's called the Tarantula Nebula. Again, my favorite, HOS, and it is difficult to image because it seldom rises very high above the horizons. And I was lucky that I did this all in one night, very lucky, without any clouds, and throughout the nights. I think it is quite a lot of data all done in one night. Okay, so it is also possible, Tarantula Nebula, and this is actually in the Large Magellanic Cloud. Okay, so you know how low this Large Magellanic Cloud can be in Malaysia. And this is M27, the Dumbbell Nebula. So yeah, it is a very common object that and can easily even image in KL itself using narrowband. Okay, so yes, this is another one, which is the Ring Nebula. Okay, so Ring Nebula is actually quite a small object. So this is actually imaged through a balloon on top of my telescope. Okay, so you can see this is actually a planetary nebula. So planetary nebulas are those stars that reach the end of their life. They popping out all the gases, okay, and these gases actually crash into each other. This form these beautiful rings. Okay, so this envelope of envelope over envelope of gases that uh, expanding. Okay, all these expanding gases. So this is actually the Carina Nebula, which is also a southern object. It's a very large and bright object, and this all can be done inside a light polluted city like Kuala Lumpur. Okay, so beside that, you can sometimes get some other things that usually cannot or are never expected to see. For example, in between these two buildings, I think you know this is near, if you are familiar with KL, this is actually near Centra, and this is Polaris. Okay, and over here, this is the International Space Stations that they have flown directly on top of my observatory. So all these things can actually be done even in KL. Now, this is M16 Eagle Nebula. So this is a very famous nebula, and I did it in SHO, follow the Hubble palette. The reason is that the original pillar of creations was created using the same color scheme. Okay, so you can see that this Hubble pictures is actually done by stitching 32 frames. Okay, a Morse set of 32 frames, and using my telescope, this thing is appear like a teeny weeny patch only. So you can see the resolutions of Hubble, uh, which is in space. So it doesn't need to deal with the atmosphere or weather issue that we deal. We need to deal on the ground, right? Now, okay, for the next part, I will present it in Bahasa, Malaysia. Okay, so yeah, okay. Malaysia mengambil bahagian dalam dua pertandingan astronomi, yaitu IOA dan IAO. MOAA ialah pertandingan yang dianjur oleh Starfighter untuk mencari bakat pelajar-pelajar sekolah menengah untuk mengambil bahagian menjemput satu pasukan bertanding di Olimpiad antarabangsa. Okay. Dan juga ada satu IO yang dianjurkan oleh MYAO Secretariat. Okay. Nah, apa ini International Olympiad? Okay, on Astronomy and Astrophysics or IOAA. Ini ialah satu pertandingan antarabangsa untuk sekolah menengah. Okay, pelajar-pelajar sekolah menengah. Syarat ia ialah peserta tidak boleh belajar di mana-mana universiti, dan umurnya mesti di bawah umur 20 sebelum 30 hari bulan Jun pada tahun bertanding. Di pertandingan ini mereka mesti menyelesai soalan-soalan teoretikal, data analisis, pencerapan, dan juga ada pertandingan team competition di mana peserta-peserta di merata-rata negara mendukung satu tim, satu pasukan bertanding. Okay? Pertandingan ini berlangsung selama 10 hari. Dalam di IOAA, semua kos dibelanja oleh negara yang menganjurkan pertandingan ini. Hanya untuk menyertai pertandingan ini, kita hanya belanja tampang kapal terbang untuk pergi ke tempat itu. Okey, itu saja. Okey, tapi kalau ini negara yang menganjurkan adalah di Eropah atau di Amerika Selatan, tampaknya memang mahal sikit. Okey. So, okey. Ini ialah sejarah Malaysia bertanding dalam pertandingan IOAA ini. Dalam tahun 2013 ialah kali pertama kita bertanding, dan ini bermula dengan satu cikgu Chan Wei Hao. Dia adalah pioneer atau orang yang pertama memperkenalkan dan mengatur penyertaan Malaysia dalam pertandingan ini. Okey. Dalam kita tidak dapat apa-apa peringkat pada tahun itu. Kali kedua juga kali pertama saya menjadi ketua pasukan. Okey. Ya, kita bertanding di Menggalang, Indonesia, dan dapat satu honorable mention. Dan pada tahun 2016 kita dapat dua honorable mention. Sungguh pun kita hanya menghantar 2 orang pelajar sahaja. Okey. Dan warna biru ini ialah mewakili pertandingan sebelum Starfighter menganjurkan MOA. Iaitu MOA ini untuk memilih ahli-ahli pasukan dianjur oleh sekolah-sekolah sendiri. Okey. Di sekolah-sekolah biasa ini di Pulau Pinang, di Selangor, di Kuala Lumpur. Tidak termasuk sekolah negeri-negeri yang lain. Okey. Pada tahun 2017, Starfighter mengambil alih menganjurkan MOAA. Kita menjemput semua sekolah di Malaysia, termasuk sekolah kerajaan, sekolah swasta, sekolah agama, dan juga college. Okey. Untuk bertanding dan memilih pelajar-pelajar yang sesuai, yang berbakat untuk bertanding di antarabangsa. Kita hantar 5 orang students, 5 students, dan juga saya dan Derek Lim adalah ketua pasukan. Kita dapat satu honorable mention dan satu international team runners up. Okey. Tahun 2018, Encik Chan Wei Hao dan Encik William Chin yang adalah ketua pasukan, kita menang peringkat gangsa yang pertama dan juga dapat satu honorable mention. Okey, dia juga student sama juga dapat international team champion. Okey. Dan tahun lepas di Hungary kita hantar 5 orang pelajar menyertai IOAA ini dan dapat 2 peringkat gangsa dan 1 honorable mention. Ini ialah satu kejayaan yang terbaik setakat ini. Okey, ini di Menggalang. Okay, 2015 Justin Tan. Ini di India. Okay. Nah, mengapa kita menganjurkan MOA ini? Ialah untuk menggalakkan pelajar-pelajar mempelajari ilmu astronomi, okay, dan juga memilih student yang berbakat dalam bidang ini. Cara kita menganjurkan ialah jemput sekolah-sekolah di Malaysia, semua sekolah kalau boleh, dan kita guna teknologi sebab Starfinder bukan sebuah organisasi yang mempunyai wang, mempunyai ramai orang yang boleh mengambil bahagian untuk menganjurkan pertandingan ini. Oleh itu kita guna teknologi. Cara kita ialah ada dua peringkat pertandingan. Peringkat pertama ialah secara online. Okay. Yang 30 best student, okay, yang menang dalam online competition akan dijemput menyertai satu camp, di mana di camp ini kita bertanding lagi untuk mencari 5 student yang terbaik untuk mewakili negara dalam pertandingan antarabangsa. Okay. So ini ialah apa yang berlaku di tahun 2017 yang kita dapat 170 student yang mengambil pertandingan online dan 24 student, okay, menyertai camp MOAA ini. Ya, ini berlaku di Kuantan High School, Kuala Lumpur. Okay, kita ada 3 speaker, 4 lecturer, dan kita dapat 18 sukarelawan yang membantu kita dalam camp ini. Okay, ya. Dan ini adalah IOAA 2017 di Phuket. Okay. Juga sama yang kali ini kita ada 400 lebih student yang ambil online competition ini. Okay. Dan juga 30 student yang menyertai camp, dan kita dapat 9 orang sukarelawan. Okay. Okay, yang ini apa terjadi di Hinghua pada tahun itu. Okay, ini Cikgu Chan, William, Yong Seng. Okay, dia memberi lecture. Okay, ya. Yang ini ialah peserta-peserta IOAA 2015 yang balik membantu sebagai sukarelawan. Okay. So dalam camp ini kita juga ada sebuah workshop yang buat teleskop sendiri. Okay. Ini teleskop ini dipanggil DIY teleskop. Okay, ini ialah di Beijing. Beijing ialah pertama kali kita dapat satu peringkat gangsa yang pertama untuk Malaysia. Okay. Dan ini ialah MOAA 2019. Okay. Ini dianjur oleh Ministry Mestek dan Planetarium negara dan juga Starfinder. Kita menjemput seramai 2,604 sekolah dengan email dan 367 student mengambil online test, dan ini ialah camp yang terpanjang 5 hari 4 malam. Student ini dan juga sukarelawan dan juga lecturer semua camp di National Planetarium. Okay. So ini yang apa berlaku. Okay. Mereka ambil peperiksaan sini, membuat pencerapan, lecture ni. Dan juga kita selepas pertandingan di MOA ni, kita sudah pilih 10 orang student, 5 sebagai pasukan Malaysia, yang 5 backup. Mereka dilatih di Langkawi National Observatory, ya. Ini lecture. Kita bagi lecture dia, kita bagi pencerapan menggunakan teleskop ini. Okay. Mereka sedang assemble teleskop sendiri, ya. Okay. So ini ialah di Hungary. Di Hungary kita dapat 2 peringkat kanser. Okay. Ya. So Jalo Gemilang terbang di Hungary tahun lepas. Okay. Okay. Nah, ini ialah syarat-syarat masuki universiti di NTU Singapura. Satu syarat ialah kalau mempunyai peringkat IOAA, entrance exam is exempted. Okay, tak payah ambil peperiksaan terus masuk ke universiti. Inilah satu kelebihan kalau dapat peringkat dalam pertandingan ini. Okay, kalau siapa yang berminat, awak boleh melawat laman internet web Starfinder moaa.starfinder.org.my untuk mendapat maklumat yang lanjut untuk pertandingan MOA. Tetapi tahun ini tidak ada IOAA sebab of COVID-19. Okay. So tahun 2009 juga ada ini negara Romania mengumumkan mereka nak mengancur ini MOA Junior yang pertama, yang ini tarikh sudah tukar, yang pada Mac 2020 ini. Tetapi itu sudah dipatahkan sebab COVID-19. Okay. Pertama kali sudah dipatahkan. Okay. Now we look at the last part of today's talk. Okay, why astronomy matters. Okay. So, I'm switching back to English. So, this is something that happened on the 15th of February 2013 over a part of Russia. Okay, and you can see a bright object flew across the sky, and it's so bright that in the early morning it's cast shadows on the ground, and it's actually recorded by all these dash cam, right? So yeah, it's a very, very bright, and this object also shattered all the windows when it entered the atmosphere at the speed of about 25 the speed of sound, or Mach 25. So a lot of people were injured, and actually this object never hit the city. It just fly over it and hit and actually landed in a lake. Okay, so this object is actually a meteoroid, or a big one. Okay, a big meteoroid. They estimate, if I'm not mistaken, is about 20 meters, about the size 20 meters or something like that. The shock wave that it generated has managed to create havoc in a city like this. Okay, so just imagine something bigger that happened to hit Earth. What will happen? This is what exactly happened. It's over 65 million years ago. Okay, so there was an object, either asteroid or comet, that hit the Gulf of Mexico. So when this object hit, the Gulf of Mexico, all the debris that during the impact covered the atmospheres for more than 10 years. So what happened when that happened? So that time the earth was dominated by dinosaurs. Okay, dinosaurs are very big. Okay, as compared to our species, we are part of the mammal family. We are very small compared to dinosaur. So what happened when the atmosphere was covered? The most of the dinosaurs are plant-eating animals. Okay, so without sunlight, all the plants die. The plant-eating dinosaur die as well. Okay, so another type of dinosaur, they are eating meat, so meat-eating dinosaur, okay, or carnivores. So after the plant-eating dinosaur died, they can eat the carcass of the dead plant-eating dinosaur. But eventually, they also run out of food. Without food, the carnivorous dinosaur also died. Okay, so leaving the smaller creatures called mammals. Mammals at the time is about 2 or 3 times the size of an elephant, but it's considered small. Because they are small, they require less food and they are adaptable, so they manage to survive for until the sky is clear and the plants start growing again. So because of this impact, all the dinosaurs were extinct. Okay, so technically this can happen again. Okay, this event is called the Cretaceous Paleogene extinctions event. So right now we have the technology to track over 99% of any objects can cause a massive extinction like this. But we still have 1% we cannot track because all these objects are very dim. All right. So yeah, with the knowledge of astronomy and observation like this, we can detect objects that threaten to the extinctions much earlier, and definitely we can have the technology to actually mitigate it or even avoid it by moving the trajectory of the objects 10 years or ahead of time. So if the impact is going to be 10 years from now, we can just make minor cost adjustment using whatever technology we have on the asteroid or the comet. The author is cost, so to avoid Earth entirely. Only if the object is very close to Earth, then we will be in danger because we do not have the time to react. Now, this is actually a problem. This is an image taken by the 4-meter Blanco telescope in the Inter-American Observatory. These are the Starlink satellite launched by SpaceX. So all these satellite is causing a problem with astronomy observations. Now, ground-based observation is still very important to us because we can have space telescope to cover many areas, but bear in mind, many discoveries are made by amateur astronomers and also by ground-based observations. And without them, we actually lose a lot of capability to detect any near-Earth objects that are going to threaten our existence. So this has becoming a problem as thousands of these satellites are going into space. Okay, so this is why we need to learn more about astronomy. One of the reasons. Okay, now right now we also know about global warming. Okay, the reason of global warming, as we know, is we actually create a lot of greenhouse gases, and all these greenhouse gases are actually melting the polar ice, and the earth is getting warmer and sea levels are rising. At the same time, yeah, the other parts of the earth is actually become more and more dry in another extreme. So this is what they call the extreme weather. So eventually the earth will one day a difficult place to stay if the population continue to grow, and we have all these harmful gases and lesser land, habitable land, due to the rising seawater. Yeah, so we have to somehow find another way. It's very difficult to stop population growth, so we may have to move some part of the population away from Earth. And also resources, when Earth resources is depleted, we can get our resources somewhere else from space. Okay, so another reason is that you can take part in learning about astronomy, learning about engineering, learning about science, to contribute to the existence of uh, our future or the future generations. Okay, so besides keeping yourself healthy during the COVID-19, okay, you should also thinking about keeping our planet healthy. Okay, so that's about all that I have for you today. Okay, so any questions? So let me switch on this. So now you see me now. So I have some questions here. Our sun is actually a G star, okay? Large Magellanic Cloud, how low? I can't remember. I think it's less than 20 degrees, okay? Yes, all the deep sky objects were taken under light pollution sky. Actually, I have more objects that I took from IOP, but yeah, I didn't show it on this presentation because the objective here is to answer the questions about whether we can do deep sky imaging in KL. Gonna buy a longer focal length telescope. Yes, William, thanks for your sponsorship. So everybody hearing this presentation know that William Chin is going to sponsor me a telescope with longer focal length. Thank you, William. Okay, any questions? Any more questions? Please post it on the YouTube chat. I'm sorry about the technical issues. I accidentally checked an extra checkbox in the Streamlab program, so it causes the screen to be redirected to somewhere else. So that's the reasons that you guys can't see the slide initially. Any more questions? So no questions. No, you. Uh, okay. Never mind. This is a joke. All right. If no questions, I will end this presentations, and my apology again for causing the initial technical issue. Okay. Thank you very much. We will wait his sponsorship to Mr. Fong. Okay. Oh, okay. Planetarium Negara. Oh, can we image asteroid 2018 VP1 this November? I'm not sure. Depends how bright this asteroid can be. I'm not sure. What are the best scope for NEO? Usually NEO they use a wide field telescope, okay, to detect NEO, near Earth object. The reason of that is because it covers a larger area, and the method that for detection is is by comparing a series of pictures. So when you compare a series of pictures, and you will notice that something will move like a movie. So let's say you take pictures every 5 minutes, like a time lapse, and you replay back all these 5 minutes pictures and you can see an object that moving in the background. It definitely will be a planetary object. It can be an asteroid, it could be a comet, and it can be a satellite, a man-made satellite as well. So usually they use a wide field telescope to cover a larger area. Any more? We still have a bit of time. Thank you, Planetarium Nagara, as the witness that William is going to give me a long focal length telescope. Okay, actually it's not, yeah, I think that's Simon's questions, right? Okay, a telescope usually we actually can't tell how far it can see. So the telescope itself is actually a time machine. So lights come from very distant. The farther the lights come from, the dimmer it becomes. So a small telescope, if you do a very super long exposure under a very good sky, you actually image very deep into the universe. Okay, of course, due to a 8-inch telescope, your collecting area you need to do longer than a 16-inch. Okay, so that is the logic behind it. So you can do very long exposure. The longer exposure, you'll see very deep into the universe. Remember Hubble Deep Sky? Hubble Deep Field (HDF), they do a very long exposure and they discover a lot of galaxies during that exposure. And Hubble is actually not a very big telescope. Okay, it's about 2 meters if I'm not mistaken. If you don't mind, would you suggest the tips of how to get started with astrophotography? Very simple. After this COVID-19, join Starfinder Imaging and Observations Party (IOP). We have this event on a monthly basis, and we bring our members to remote area, safe and remote area, to do observations and imaging. Okay. Any more questions? Another thing I forgot to mention, Mars oppositions. So now is a great opportunity to image the Mars. Okay. Currently, any effort to study NEO. Are you referring to, Simon, are you referring to in Malaysia or internationally? Malaysia have a problems of weather. Usually during NEO research, we need continuous good weather for imaging. Okay, so Malaysia is not an ideal place to do NEO. But we did an experiment. Few of a Starfinder imaging kaki did an experiment. We discovered that we actually can use infrared to to image and able to actually detect asteroids, a few very dim asteroids, which is beyond the capability of normal visible light imaging. So this is an area that we can explore. Yeah. Still no scope to take Mars planet. I am as astro hobby. I'm at your same shoe. My mouth has broken down last month. Okay, and now it's a holiday in China. I'm still waiting for the parks from China, so will arrive only end of the month. So I think I will miss Mars. If the parks arrive, I still have a bit of time to do it, but I think I will miss the best time of imaging Mars. I think William will take the opportunity and waiting for the weather to improve. So rain and cloud go away and let astronomers come out to play. More questions? I thought you're gonna camp out until for the next 10 days, 10 nights. Yeah. I think we should have a planetary imaging workshop. What do you think, William? Do they allow people to astrophotography in Malaysia's public observatory? Uh, Depends. You can always write in and see whether they have. Yeah, I went to a few private observatory. They are quite welcoming, but you have to know the owners, and they usually, I mean, may not use their equipment unless the equipment is free. But you can bring your equipment and use it in the observatory. I went to CK Observatory and I brought my own equipment. Okay, so yeah, usually astronomers in Malaysia are very welcoming. We are friendly people. We are not some alien species. uh, I'm not sure. I'm not sure. There's a lot of hidden hidden dragon crouching tiger in Malaysia, so I wouldn't know who have the largest amateur telescope. Okay. Yes, William, you heard me. Workshop on planetary imaging. I think you should conduct one. Maybe after the Mars opposition. I know you will be busy. Maybe an online workshop. This way of talking to people using voice and people reply me in text is quite a weird. 14 inch. The telescope in Teluk Gamang, is it privately owned or owned by the government? I believe it's privately owned. Okay, now, so Planetarium Nagara say workshop. Yes, please. So can Planetarium Nagara be the host of this workshop? Which type of telescope is best for planetary imaging? SCT, Maksutov, these are very good telescopes for planetary imaging. The famous, of course, the Celestron and all those, yeah. Yeah, C14, Celestron C14, yeah. Big monster. So, any more questions? Hey, you guys all know me in Facebook, and you can actually check with me during the normal time. You don't have to check here, right? Okay, if no questions, I end the stream now. Okay, and thank you very much for attending my talk, and also thank you Planetarium, thank you Maisa for arranging this, and yeah, uh, Starfinder, we will also conduct a series of talks in the near future. So please stay tuned and pay attention to our Facebook page. And you would like to, if those who like to participate in future international or Olympiad competitions, also can visit our moaa.starfinder.org.my website. We will always have questions, and we always have some information there. You can also try out some questions and see how easy or difficult